Good morning, class. I was just about to make the answer key for this long-term review, and I thought I might as well film myself doing it, so I'll put this up on Thursday, the night before the test, so you can use it to review. So here we go. Number 1, find the slope of the line that passes through the 2 points. So in order to do that, I'm going to use the slope formula, y2 minus y1 over x2 minus x1. And so that's 5 minus 2 over negative 3 minus 9. And so that is 7 over negative 12. Then describe the line as rising, falling, horizontal, or vertical. So with a negative slope, I can automatically say that it's falling. If I was really not sure, I could graph 9, negative 2, and negative 3, 5, and I can see that it's falling from left to right. In number 2, I've got to go one step further. I need the equation of the line that passes through these 2 points. So there's a couple of different ways I can do that, but always I want to start with the slope. So I'm going to use my slope formula and plug in the values. 2 minus 4 over negative 3 minus 5. Work out the math, and that is 6 over negative 8, and I'll reduce that to negative 3/4. So now I have a slope, and I can pick a point, and so I will use my point slope formula and substitute the values. So y minus y1 equals m times x minus x1, which the x that goes with 2 is negative 3. So minus 3 is the same as plus 3. And I want this in slope-intercept form, so I'm going to add 2 to both sides. And I'm going to distribute and combine like terms. So I'm kind of running out of room here. So let's see. After I've added 2, I end up with y equals negative 3/4 x. And then negative 3/4 times positive 3 is negative 9/4, and negative 9/4 plus 2, well, negative 9/4 is negative 2 1/4, and plus 2, that's minus 1/4. So there's my final answer. In number 3, I want to write the equation of the line in slope-intercept form that passes through this point and is perpendicular to this line. So the slope of my original line is 4, but I don't want to use that slope because that would be a parallel line. I want to know what the perpendicular slope is. So I take the opposite reciprocal. So now I don't need this slope or this equation anymore. I need my new slope of my perpendicular line and my point. So now I have the slope that I want and the point, so I'm going to use point slope form. Y minus y1 equals m times x minus x1, and minus 5 is plus 5. So let me distribute. And then I'll add 8 to both sides. So plus 8, plus 8. So y equals negative 1/4 x, and negative 5/4 plus 8, I'll just use my calculator, negative 5/4, no, 5 negative divided by 4, oh, there is a decimal point in there, so negative 5/4 plus 8, 6 3/4 or 6.75. So there's my equation of my perpendicular line. In number 4, I'm determining if each relation represents a function. So I see that I've got, well, I was on alert because the negative 2 is listed twice, but since it has the same value, that's okay. If it had had 2 different values, then no. So yes, this one's a function. In number 5, I use my vertical line test. So yes. Alright, in number 6, I'm going to use this piecewise function to find f of 5. So I need to know where I should plug in a 5. I've got less than or equal to 5 or greater than 5. So I'm going to plug 5 into my first function because that's the domain where 5 is located. So 2 times 5 plus 3, I get 13. 0 is down here also in this less than or equal to 5 section. So 2 times 0 plus 3 is 3. And then 8 is up in this department in the greater than 5 section, so I would do x squared minus 4 at f of 8, so 8 squared minus 4, that's 64 minus 4 is 60. In numbers 7, 8, and 9, I'm finding the domain of each function. So pretty much, when I'm talking about domain, I can't divide by 0, and I can't take the square root of negative number. So there's no division in this problem and no square roots, so my domain is negative infinity to positive infinity. In number 8, I see I have a denominator with an x in it, so I need to figure out what value of x would make my whole denominator 0 and make me not allowed to do it. So if I had x was negative 2, that would make it be 0. So I can have any number in the world except for negative 2. So this way of writing the domain excludes negative 2. And then in number 9, I have a lot of values that I can't use because if I want to kind of look at the border, like I can take the square root of 0, but I can't take the square root of anything less than that. So what value of x would make this quantity underneath the radical be 0? And so if x were 7, 7 minus 7 is 0, so 7 is kind of my cutoff point. So, but I want to know, is it the numbers greater than 7? Is it the numbers less than 7? Where is my domain? So if I try a number greater than 7, like 8, and see, does that work? 8 minus 7, that's the square root of 1. Yes, that works. So I basically can tell from just logically thinking it out that the numbers greater than 7 are okay. It's those numbers less than 7 that I have to worry about. So I can start at 7 with my domain, and pretty much anything greater than that is going to give me a value that is positive, so I can take the square root of it. In number 10, I'm looking for domain and range of these two functions. So I know that a quadratic has a domain of negative infinity to positive infinity. There's no value of x that I couldn't plug in and get a value for, but I can see very clearly that my range, there's no value of y that's below 2. So my range starts at 2 and goes up to infinity. In number 11, this is a square root function. I can see that it is at 3, this point is 3, 2. So that helps me see that, okay, to the right of 3, there are x's that are represented in the function, but there aren't any to the left of 3. So for my domain on that one, I would say starting at 3 and going to infinity, and then the same for my range. There are values at 2 and above, but nothing below that. So I'm going to start at 2 and go to infinity. Next page. In number 13, we're given a function f of x, and we want to find the relative maximum and relative minimum. So we would want to use a graphing calculator or Desmos for that, and then describe the intervals where it's increasing, decreasing, and constant. So I'm going to pause the video and grab my phone.